Welcome to Module 1, Lesson 2, Sets of Real Numbers. Today we're going to talk about identifying irrational numbers. Alright, so first what we need to talk about is we need to talk about what real numbers are. So we've talked about irrational numbers. We know that those are numbers that have decimals that go on forever without repeating. Well, real numbers are what both rational numbers and irrational numbers fit into. So what that means is, if you're looking at this in terms of our circles, we have whole numbers, integers, and then rational numbers is its own big circle. Irrational numbers are out here by themselves. They do not intermix with with rational numbers and integers. And then you have real numbers that cover both irrational and rational numbers. All right, so it's kind of like they wanted to find there's a way to put rational numbers and irrational numbers in the same bubble. Okay, so here we're going to take a look at writing all that apply. So in this case, the square root of 5. Well, we know that 5 is not a perfect square. Since 5 is not a perfect square, it's going to have a decimal that goes on forever. Since it has a decimal that goes on forever, it is going to be irrational. And because it's irrational, we also know that it is real, because all irrational numbers are real numbers. In this case, I have negative 17 and 84/100ths. Okay, it doesn't go on forever without repeating, so therefore it's not irrational. It is rational. Let's see if it fits with integers. Well, integers can't have decimals. Since this has decimals, we know that it can only be a rational number and a real number. Now in this case, I have the square root of 81. Well, the square root of 81 over 9. Well, the square root of 81 is equal to 9 because we know 81 is a perfect square. So here I have 9 over 9, and I know that 9 over 9 is equal to 1. Well, since it's equal to 1, I know that it is a, well, we can start backwards. It's a real number. It is rational. Or actually, let's start from the inside. Is it a whole number? Well, it's not negative, so yes, it is a whole number. Is it an integer? It doesn't have a decimal or a fraction, so it is an integer. It is rational because it does not have a decimal that goes on forever without repeating. Or, well, it has a decimal that goes on forever because this would be 1.0000000. So technically it does have a decimal that goes on forever, but that 0 does repeat. So in this case, it is a rational number. And because it's a rational number, we know that it is real. Because all rational numbers are real. And all integers are real. And all whole numbers are real. All right. So now we're going to write all the names that apply to each number. So a baseball pitcher has pitched 12 2/3 innings. Well, I know that 2/3 is equal to 0 6/10, but that 6/10 repeats. It goes on forever. So since that 6/10 repeats and goes on forever, since there's a decimal, I know it can't be whole, and I know it can't be an integer. But since that 6 repeats, I know it's a rational number. And since it's rational, I also know that it is a real number. Here, the length of a square, or of a side of a square that has an area of 10 square yards. So what they're saying is they want to know if the length, so down here, we want to know if this is whole, integer, rational, irrational, etc., etc. Well, I know when I do a square, it's side times side equals area. In this case, that could tell, or that also means that it is side squared equals area. So let's put that in terms of what we know now. We know that the side squared is equal to 10. So I know that to solve this, I'm actually going to copy and paste this one more time. So I know that to solve this, I have to square root both sides. So if I do the square root of s squared and the square root of 10, I know the square root of s squared is equal to s, but since 10, even though we want to think it is, 10 is not a perfect square. Look at it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That gives me a rectangle that is not a perfect square. So I know that since it's not a perfect square, that this number is going to go on forever, making it irrational. And since it's irrational, it's also a real number, because all irrational numbers are real. Okay, so now we're going to figure out if the given statements are true or false. And then you have to think about your characteristics for all numbers. So let's write those down again. So whole numbers, they have to be, positive, no decimal, no fraction. Okay, to be an integer, it can be positive or negative, no decimal, no fraction. To be rational, it can be positive or negative. It can have it can be written as a fraction or a decimal, but those fractions or decimals, they have to terminate or repeat. Okay, and then I know real numbers are the set of all rational numbers and all irrational numbers. And then I know irrational, positive or negative, have to have a decimal that goes on forever without repeating. Okay, so now that we've established our characteristics of our numbers, of our different kinds of numbers, all rational numbers are real numbers. We'll look at the definition. Real numbers are all rational numbers and all irrational numbers. So in this case, this would be true. And this is true because real numbers are the set of all rational and irrational numbers. No rational numbers are whole numbers. Well, let's take a look at this. To be rational, it's positive or negative, and it can have a fraction or a decimal. It doesn't have to have a fraction or a decimal. I should put can have a fraction or a decimal, but it has to terminate or repeat. So in this case, it can be positive or negative. So we have, in our whole numbers, they have to be positive. And since this can have a fraction or a decimal, it doesn't have to. So if it doesn't have a fraction or a decimal, it can still be rational. So it can have fraction or decimal. So in this case, no rational numbers are whole numbers. That is false. Because, so it's false because a whole number, to get into the very nitty-gritty of it, a whole number can be written in the form of A over B, where B is always equal to 1. In our terms, it would be, or plain and simple, false, because whole numbers can be or are positive and have no fractions or decimals, and rational numbers can be positive and don't have to have fractions or decimals. Right, so it is false because of the fact that whole numbers can be written in the form of a over b. So look at it this way. 4 written as a over b is 4 over 1. And that's always a rational number. All right, so all rational numbers are integers. Well, I'm going to go back and I'm going to grab my words here. Right, so I know that whole numbers, they're positive and negative, my integers, my irrational, my real, I'm running out of space here, and then rational. So all rational numbers are integers. I want you to try the two of these on your own and then come back and check your answers. So this is false because rational numbers can have decimals that repeat or terminate, but integers can't have decimals. So not all rational numbers are going to be integers. For example, 1 and 5/10. It's a rational number, but it is not an integer because it has the decimal. Or 2 and 1/2. It's a rational number, but it is not an integer. Some irrational numbers are integers. Well, this is false because irrational numbers have to have a, ran out of space, decimal that goes on forever without repeating, and integers can't have decimals. Therefore, no irrational numbers can be integers. Right? Again, you always just have to go back and look at your characteristics and see if they fit. All right, identifying sets for real-world situations. So this is our last little piece here. So real numbers can be used to represent real-world quantities. Highways have posted speed limit signs that are represented by natural numbers, such as 55 miles per hour. Integers are on thermometers. Rational numbers are used in daily activities like cooking and things like that. So what we're doing is we're saying, okay, well, if I'm looking at this, let's look at A. The number of people wearing glasses in the room. Is that going to be a set of whole numbers, integers, rational, irrational? We're looking for the best example. Well, can we have half of a person that is wearing glasses? The answer to that would be no. All right, so since we can't have a half or a part of a person that's wearing glasses, we know that this would be, and we can't have negative numbers, so we can't have negative people wearing glasses. So we know that this would be represented by the set of whole numbers. Since a partial person can't wear glasses and you can't have negative numbers of people, the set of people wearing glasses is best described by the set of whole numbers. Okay, the circumference of a flying disc that has a diameter of 8, 9, 10, 11, or 14 inches. So here you have to know your formulas. So the circumference of a circle, is equal to, C is equal to the diameter times pi. Don't know how to write pi with my thing, so with my keyboard, so pi times diameter will have to do. Since I know that pi is an irrational number, I know that anything that I multiply it by is going to be irrational. So since pi is a part of solving for circumference, I know that any answer that I get will be irrational. So the circumference of the disks are best described by the set of irrational numbers. Goodness, that's a lot. Okay, so I have to use what I know about common sense and about formulas to help me determine that all of these answers are going to be irrational because of the fact that pi is irrational. All right, so now what I want you to do is I want you to try these and then come back and check your answers. So the amount of water in a glass, okay, as it evaporates. So in this case, the amount of water is always going to be larger than 0, but it can also have a fraction or a decimal. So because it can have a fraction or a decimal, this is best represented. So the amount of water in a glass as it evaporates is best described by the set of real numbers. Because at any point in time, there is any number greater than 0 in the glass. Okay, so even though your answer really here can't be negative, it can still be represented by all these other numbers that are still part of rational and real. So the one that includes the most would be real numbers. The number of seconds remaining when a song is playing displayed as a negative number. Well, since it's displayed as a negative number, we can say that it is represented best by real numbers because they can have decimals and be negative. Again, we'll get a lot more practice with this when you guys come to class. We are only spending 1 day on this, so please make sure that you take your time and do your best with your definitions and characteristics. What I would like you to do here is I'd like you to answer the questions and then transfer them over to the Google Classroom. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.